All right, welcome back to the DAC Pavilion, everybody. So we now have a panel, Function as a Service in the EDA Cloud. It's my pleasure to introduce Ben Jordan of Jordan DSP, an industry consultant who will be moderating the panel, and he'll take it from here.
Hi, welcome everyone. Thanks for coming to our panel discussion. Very quick question for all of you. And this may seem like a stupid question, but who's heard of software as a service here? Yeah, give me a wave. Yeah, everyone knows what software as a service. Okay, but who before reading about this panel discussion at this conference this year had seen the phrase function as a service or FaaS? Anybody? Anybody familiar? No, so that's why you're all here. You're here to learn something new, and I have a panel of really good experts here with me today. I'm very happy to introduce them. So starting out, we have Rajath Narasimha from Keysight. He is an EDA product manager and knows the ins and outs of how to make an EDA tool work better and faster for the users. We have Yi Chao. Did I say that right, Yi?
Yeah. Perfect.
From Meta. Meta's here. Yi is here from Meta to represent what is it like for an actual end user to need to embrace the new way of getting things done faster in simulation and other aspects of EDA. And I would say he's a SIPI, high-speed design expert, so exactly the kind of person that needs acceleration in electromagnetics, simulation, and other types. We have also representing the back end of SaaS and FaaS and high-performance computing on the cloud, we have Ken Hill from Eviden. Now, not to be confused, he is wearing an Atos shirt, but there is a current business operation going on with Atos and Eviden to where there'll be a new company coming out of that, if I get that right.
Yes.
We also have representing the solution providers for high-performance compute in the cloud, Ryan Magruder from Rescale. So welcome, guys, and thanks for coming. What I want to do is start with maybe Rajath. Give us a quick overview from an EDA point of view.
Yeah.
What is function as a service, and how can that actually help EDA customers become more effective in their role as design engineers and get more out of their tools and become more cost effective as well. So,
Okay. That's nice. Yeah, thank you, Ben. So to give you guys a quick introduction of an EDA architecture, given the state of our design, a lot of our tools are still very monolithic. What that means is we have one big software which builds as an image, which has the IPs, the libraries, the dependencies, the packages, all built in one, which is great for the fact that it helps you have trade-offs quicker. But what it lacks is the flexibility and the scalability for our end customers. So what functions as a service does really is it breaks up the entire monolithic architecture into small chunks of code where the designer needs to just worry about the application layer. They don't need to worry about the layers which is getting abstracted below. So that in itself is functions as a service.
So from a user perspective, it doesn't really look any different. They're using their EDA tools the way they've been trained and know how, and it's just going to operate a lot faster. But the contrast with current or traditional high-performance compute versus function as a service is we can do a whole lot of small compute operations a lot faster, and we get more scalability. So that sounds very, very compelling to me, but I'm curious about the overheads. I'd like to hear from, say, Ken, if I'm breaking up a simulation data set, so we're talking two things here. We're talking complex mathematical algorithms, lots of matrix manipulation, and things that could go faster with a GPU, say, or maybe hardware acceleration, and that's great, but I also have a big chunk of data. You know, we have very large data sets. So how is that going to be broken up and be made more efficient by using function as a service versus traditional high performance compute?
Right, so the thing about function as a service is it's almost like if you're all familiar with doing libraries, or you know all the supercomputers are on the benchmarks, right? So if we use a kernel, we can break apart our data set, and you only send the data that needs to be computed. And I think what we would do is, based on what operations you're doing, you'd pick what type of compute you wanted to use, and you just hire your utilization. So instead of sending your whole check mark and then sending that off to an external server, you just package the data that was part of your operation, and that would be sent to compute. And then you'd either send that, the result of that, you'd send it to the next step, or maybe you'd send it back to your, your calling application.
Yep. Ryan, do you have any comments on that one as well from the provider's perspective?
Yeah, I think it can be very valuable just in terms of another layer of abstraction from end users to help us drive adoption for these tools. I think looking at app or infrastructure as a service to start, where we've removed the ability or the necessity to manage the underlying hardware, platform as a service and software as a service, kind of removing those needs to maintain OSs and software, and function as a service is an evolution of that, where we're even removing the need to have any underlying knowledge of the hardware that you're running the applications on. So just taking that out, you're removing points of failure. You're giving people access to hardware faster with less latency. It has the ability to provide a lot of value on both ends for users and IT organizations.
That sounds promising. So, Yi, I'd like to ask you about that. As you are an early adopter of cloud high-performance computing for simulation especially, what are you seeing currently, and where do you feel it needs to go to be a technology that really is enabling anybody using EDA tools to become more efficient, to do more, and perhaps what are some of the pitfalls that you've encountered as an early adopter, if you don't mind sharing?
Yeah, sure. Yeah. Thank you, Ms. Jordan, for the great introduction. Yeah, very delighted to share some perspective or some insights as a adopter of this technology from the user perspective. I mean, this audience probably has some engineers. I think the primary goal is to accomplish very complex and yet like a large-scale problem within a very tight deadline. Also be mindful of the resources at hand. Like, how do we do the things faster but get the job done? So that's all the engineer care the most about. And I think the cloud as service or FaaS really has the potential to make it really happening, and to really make the end user to be as efficient as possible. Also being able to give the reliable result. But I think there's something that the user also to be mindful about. I think for some, I think managing that network reliably and being able to get the needed support is very important, because as early adopter, we also face some challenge on the tooling and infrastructure side, where this cloud is very kind of promising, but in the end, it's not delivering what it's supposed to do. I can give a brief example if you have time.
Yes, please.
Yeah. And recently, our SIPI team in our organization decided to migrate some of existing large-scale EM simulations into the cloud, just like this FaaS type of infrastructure. And then in the beginning, we ensure that type of problem can be executed locally in our local machine. although the efficiency may not be great, but we can still get job done. But once we migrate the whole, the database, the setup, and all the automation stuff into the cloud, what I've been seeing is, okay, so the simulation runs typically fine in the early stage, but after, let's say, a couple hours, it runs into some of the kind of unknown problem where the simulation just hangs after a couple hours. So this is something that we never encountered before, and then we reach out to the infrastructure providers, and then they kind of say, okay, this is something along the networking and the license kind of being interrupted while transmitting the HPC. So they don't know the ultimate root cause. They have to loop in expert from the EDA side, the EDA provider, and then they can help, but they also lack of the information what exactly that infrastructure that utilized by our organization. There's some uniqueness at the cloud and also the function on service side. So in the end, this become a very complex debug. We have to involve the 3 parties. We have to run a debug meeting for many weeks, and eventually we figure it out. But at early adopter, this is a significant investigation of our own time to drive that complex debug. It's really a time-consuming kind of process. I mean, looking ahead, I think really functional service should be able to provide end user a reliable and also kind of simpler to use, like a very friendly user interface. And also the throughput should be guaranteed. We cannot really just sitting there waiting, but in the end, it's not delivered as supposed to be. Yeah, that's some of the perspective I can share at the moment.
Yeah, so there's a few key issues out of that are very interesting. So reliability, guaranteed performance, or job completion time, let's say.
Exactly, yeah.
And then you also mentioned setting up the high performance compute in the cloud with the data set and the simulation. I think one of the nice things that we have in the current generation of EDA tools that have HPC, like ADS, for example, if you are using HPC, it's very easy from a user point of view to enable it and allow your simulations to run faster. Though they may not always run faster, as you pointed out, they may stop or there might be other things. So the other issue, we're introducing more parties, more providers into the loop, and so tracking down where problems may occur can be harder. So on that, I'd also like to bring it back to say, our provider guys here, Ken and Ryan, maybe start with you, Ryan. What are some of the things that you see we need to do as an industry or providers can do to help guarantee a certain level of performance and reliability with simulating in the cloud?
Yeah, I think function as a service provides an opportunity to address a lot of those concerns. A lot of the issues that you described certainly seem like they stem from taking a monolithic stack of software and trying to deploy that into a cloud environment where it may have initially been intended to be used in an on-premise environment where you have a licensed server that's sitting right next to it, the interconnect architecture, and then all of a sudden we're trying to deploy these tools in new environments where you're connecting to an on-premise licensed server from the cloud, and there are connection issues that you may not know what interconnect architecture you're running across. So those issues are going to rise as we kind of try and merge the two, different ideologies essentially. But going to function as a service is the responsibility for the maintenance of the underlying software package kind of moves a bit off of the user and the organizations onto the providers of those functions. It provides an opportunity for them to optimize, to run through and test. I mean, if that's what they're providing as a full stack solution, I do think there's definitely an option there with, they can do more testing. They can obviously say which architectures exactly this is going to run on. So it does give them an opportunity to provide a more unified experience that would hopefully address some of the issues that come up when we're trying to deploy, a legacy application in a new cloud environment.
That's good. And so Ken, from your point of view, also touches on what Yi had experienced with licensing and some of these other things. What are some of those issues you've seen as a cloud service provider, and what are the next moves for the industry to address them, do you think?
Right. So unfortunately, licensing is one of the bigger challenges we have adopting applications into the cloud, just because, the big way that most software vendors protect their revenue is to make sure that they have a license. But as Ryan mentioned, a lot of these cloud instances are ephemeral, so they only survive for the life of your job or maybe for a day or so. So the licenses are generally off-site, or even if they're in the cloud, maybe you split your license server to like some of it's still on premises and some of it's in your cloud, and now instead of having 50, you have 25 on each side or things like that. So, and generally when an application runs and it tries to get a token and it doesn't get it, the application goes in failure. So one thing that I think function as a service creates an opportunity for is if you take some of the hyperscaler cloud providers, if you're doing a matrix operation or a fast Fourier transform, why does that need to be licensed, right? So you're going to pay that cloud provider to compute that for you. You're going to pay them their revenue based on your compute time, and believe it or not, fast Fourier transform, a lot of those things they're almost like elementary operations now. They're not really something you'd protect behind IP or licenses. So I think that's a good, right now, a lot of our cloud instances, you take your monolithic application, you put it in the cloud, and it doesn't matter what small piece of it you're using, the whole application's there. So what something could do for FaaS could do is the EDA providers, as long as it's to the same specification, maybe they take out all those elementary operations that you don't really need to have a license concerns about, right? And that would allow us to mature our FaaS to the cloud. And then when we start getting to those IP protected operations, we'll already have the low-level things figured out, and hopefully the things with reliability and just the growing pains between not being on premises and being on a remote server. So hopefully we can do those elementary operations first, license free, and then just the cloud providers will get their revenue that way. And then when we get to those higher level IP protected things, we'll already have a good foundation to harden that going forward.
It does sound like a good way to go. I'm curious if any of you have any war stories you could share about unexpected or unintended consequences of adopting any of this. Maybe Raja, I'll start with you, or really anyone weigh in.
Yeah. I mean, I'm glad you asked me the question. we have burnt our hands running a few EC2 instances on Amazon and even Rescale, as a matter of fact. So there's one instance, we as admins, we do have ownership as to ownership and visibility over who's running the job and how long are they running the job. A few of the team members within, of course, they're fairly new to cloud and they want to expand their knowledge and skills and run some benchmarks. Without prior knowledge as to how much it costs and what it takes to run a simulation, a company can go bankrupt without planning for such an event. So we've had few instances where people have just launched a few EC2 instances off and then forgotten about it, come back after a week and say, hey, it didn't finish, so I killed the job. And then I get an email saying, hey, your $5,000 of credits has been burnt over the weekend and nobody got the results. So that's a pure example of hosting an entire monolithic application where the person hasn't, as a matter of fact, has no control over how long the simulation can go. And the costs are not entirely apparent because the total cost of ownership is way different to the cost you see. So what I mean by that is when you launch an EC2 instance, it'll show 10 cents an hour, 15 cents an hour. You'd get deceived saying, oh, I can run all day and not even run a few bucks. But the total cost includes the spin up time, the spin down time, the services time, the network time, and the CSP, they take a cut. So all that adds up, and eventually when you see the bill, it's not deception, it's that we are not educated regarding those things. And actually quite honestly, it's very hard to predict the cost even because when you're running a huge simulation with n number of sweep points, there isn't a logic which can determine how many licenses your job needs, which compute it needs, and is there an optimization you can perform, and at the end of the day, when the simulation finishes, how much the simulation costs. So that in itself has been a real hard challenge for us, which we are trying to solve. And functions as a service there can solve a few problems where when you're running just a circuit simulation job, you're only invoking those functions, and you're still limited with that use and scope, and not invoking the entire ADS suite of tools, which will keep running in the background.
Yes. So really, this comes down, folks, to why function as a service has even been invented in the first place, is to mitigate this problem of having a very large bloated system running on HPC somewhere, when really you could just squeeze the most benefit out of it with just the smallest pieces. But then, so another question that comes up with that, of course, is if you're breaking things up into small pieces to send those out to the cloud for acceleration, how do we know, or what can we do to get the benefit of that without the shock of, heavy network data transfer? So I'm mentioning that too, because that's another area where the company gets a bill, but the bill's gone not even to the engineering department, it's gone to IT. And suddenly their bandwidth, they're realizing there's a bandwidth problem. And IT people, not to down talk any IT people, they're wonderful, we need them. But their solution to problems like that is to throttle. They want to turn the faucet off. And so now we had function as a service working well, and we have fast acceleration. My engineering time is also very valuable to the company, and so I can do more and do it faster. Now suddenly I'm back to square one. So what are some of the things we could do, or that EDA and service providers can do, to mitigate these issues, and how can we as end users upfront plan for this and make sure we're not going to run into some of these barriers? I know it's sort of a double-barrel question, but let's start again with Ryan on this one.
Sure. I think a lot of the points Rajat brought up there about incurring costs that you don't expect, there's certainly work that can go into that, right? In terms of prediction, awareness, knowledge. The more knowledge you can pass on to the user, you expect they can make more intelligent decisions there. But there's also ways, right? If we're breaking these up into services, a lot of these data loads are going to be kind of smaller inherently, which certainly helps. But we can think about ways that we have to integrate these solutions. I mean, function as a service is a compute service. And on its own, it's great, but if it doesn't have a way to intelligently work with your data, it's going to present problems. So either finding ways to provide a full stack solution that includes a storage component where we can intelligently move files, we can transfer files to make sure that they're going into a place where they're optimized for compute, but we're also optimizing for transfer costs, storage costs. I think typically we think for other workloads about bringing your data to the compute, right? Where is my compute most efficient? Let me bring the data to it. EDA is so unique in terms of the size of the data that we need to operate on that we can shift our thinking a little bit of bringing compute to the data. Obviously, you can't bring the physical hardware, but it's about optimizing maybe the locations, the regions, even the CSPs we are executing to try and take advantage of CSP backbone networks, your own existing cloud NFS file shares. So it's a complicated solution, but the more integrations we can build, and the more offerings that function as a service tools can offer in conjunction with their compute, is going to mitigate some of those needs, definitely.
Yeah, Ken?
Yeah, I think so. And I'm sure Rescale deals with the same issues. For some of our customers, what we do is they have usually like training data sets or smaller work problems, and what we'll do is we'll group the different engineers into teams, and they'll get allocations. And normally, every customer or client's unique, and they understand their processes fairly well normally. So we'll have them run their training sets or whatnot to get a good feeling of extrapolating that out to their larger jobs, and then their managers will go back and do allocations to each team. So if they're supposed to do two projects at a time, this team will get a certain allocation over that month, and then maybe every month or whatever cadence, the managers come back and they say, okay, here's our overall bill. This is where each team used, and then if one team got too greedy, so to speak, their allocation will be cut and they'll be distributed to other people. And what we've done in our platform is, we've added that throttling ability. So it's not a great user experience, but it's also a good lesson. So if they're running, 30 simulations and their allocations maybe only for 12, that's a big problem, and it affects other parts of the company. So that's generally what we do is, we try to get people in like teams, and then like if you go to tape out, whoever has priority on the tape out, they get a larger allocation. And that's also why, cloud computing in general, but also, something like FaaS, is everyone always wants to have their own data center to some degree. But during tape out, if you need to burst out to the cloud, that allows you to meet your deadline. So I think using FaaS and the cloud, you can actually allocate your allocation. You can change your allocation over time. So during tape out, maybe you double it, but you're not increasing your capex that much because you're not buying another data center. So that's generally what we do is we try to do limits on the platform, and then the managers of the teams kind of just hash out who has higher priority.
Sounds good. Yeah. Rajath, any comments to add on to that from the EDA side?
Yeah, I think those were great points. Both Ryan and Ken, they see this problem firsthand because they are the ones trying to solve the problem, and we are the ones trying to complain or even listen from our customers.
We're the ones that get the complaints.
Yeah, that as well. I think where we see problems, we get to interact with the customers firsthand. Their comments has always been that I'm of course oversimplifying the entire problem statement and the customer journey. The expectation they have is when you open an Uber app, you're able to pick your destination, pick your commute, and choose based on where you want to go and how much it costs, and you hit yes. That is the experience they are asking, and that's where it needs to go. Where we are currently right now is not even close. Like we are at a place where we are able to submit jobs. Nobody knows how much it costs. Nobody knows what it entails. Nobody knows how many licenses that job needs. Translating the net list to the licenses to finally the price. So there's a lot of underlying infra which needs to get built in. So I believe that's where the problem is.
So you have a very robust roadmap, is what you're telling me.
Yeah, that's right. Yeah, we can always be hopeful, and given a big team with multiple people looking at it, I'm fairly positive that solution is not too far away.
Yeah, I'm quite bullish on that myself, having had some HPC computing experience as a product manager before becoming an independent consultant. I was with Autodesk for a time. Not EDA, of course, but very similar problems trying to solve, and online 3D rendering, for example, for movie creation and so on. And they came up with the cloud credits system. And obviously there's some margin built into a system like that, which is good for the software company, but it's good for the user because the user can predict, okay, this 3D render is going to take be 20 minutes and it's going to cost me 2 or 4 cloud credits. So I know roughly what the ride is going to cost in ride tickets, if you've ever been to a county fair. Yi, I'd like to bring it back to your point of view also as an early adopter and a customer of this and a signal integrity, power integrity expert. What are some of the things you would really like to see in the near future for accelerating simulation and the kinds of problems you're trying to solve at Meta?
Yeah, that's a great question. Yeah, so a lot of experts have said this function as a service really has become like a trend enabler for this newer technology. And as a user, we do see the benefits, right? So a lot of our circuit simulations or some of the design experiments can be broken into smaller jobs. And if each of them can be executed more efficiently and also paralleled while our different HPC computing infrastructure, we see a great gain. I think really what it boils down to as a user, we want to have a great efficiency enhancement with the reliability and also backed by the support from both the FaaS infrastructure and EDA tool provider. So backed by these two support, it's really enabling a lot of newer and exciting applications. And also as a user, I think also needs to be mindful about the cost. The cost is always a sensitive factor. And also as kind of more HPC license being leveraged, and so over a broader number of nodes, the cost could be kind of adding up quickly. But this is something that needs also to be managed, some upfront cost, kind of transparency, or even during execution, there's some live monitoring of the kind of time versus like billing kind of trade-off. And also, I think if there's also as a user can be dialed into this problem much more simpler, like a lot of like generative AI technology could be really beneficial. Like a user, I just tell this cloud I need 3 things to be done, and this AI will manage me how to leverage all the resources to be really kind of combined as a laser focus on a problem. I don't have to break it down based on my experience. AI will give and provide the most kind of intelligent guidance to solve the problem. Yeah, that would be really awesome.
Yes,
yeah.
It sounds very promising. Do you have any advice for anyone here who's thinking about moving in this direction as an end user? On top of what you've said already, what would be maybe the top 5 or 3 things you would recommend that they do as they move forward into embracing this high-performance compute using function as a service?
Yeah, I think at end user, I think really probably both like 3 things. First, have open-minded, being kind of open to these newer technologies, not be afraid of additional kind of pain point of complexity of the brain. And also, when try to have this implemented, you're going to have start with a small problem, right? You have a small problem, you work with both the solution provider from EDA and infrastructure. You have a small tiger team can really vast the technology over a known problem that you know the solution and you know can be solved in a reasonable time kind of horizon with your on-prem solution. Then you can compare, and then you can gradually kind of adapt that to a more complex, a more kind of sophisticated problem. And finally, I think it's really just that it's going to be a very unique application that's kind of really needs that compute and the infrastructure. Because you have some problem that you can already comfortably working with your own, say, on-prem or some non-FaaS-like infrastructure, and they don't have good automation. But if you have a really good automation, no other computer infrastructure can solve it. Really, you just have to like put your heads down, work on it to really become your unique kind of solution. That would be great.
That's good advice. I like the first one especially, to be open-minded, because it reminds me, you know, as a computer systems engineer, that's my training and background. It's this odd engineering mindset that I've had myself and also encountered a lot being someone involved in EDA is a couple of things. One is we want to own our software. We want to buy it and use it for perpetuity, right? It's this reluctance to move towards a subscription-based model. And yet, in society, everything we do consuming as consumers is more or less a subscription these days. So there's that. And the other side is data sovereignty. I think this is just my view as you're saying that, one of the purest benefits of function as a service is that by breaking the problem down into tiny little pieces, I have far less concern that my data, my intellectual property as a whole item is necessarily hosted by somebody else. It may just be each small little piece of the problem. Rajat, do you have any comments on this from and really any of you, feel free to weigh in on this. What are the comments you might add as in terms of the benefits or difficulties we might face in terms of intellectual property ownership and data sovereignty as well?
Right. Yeah. Anyone want to go? Okay. Yeah, I think that's a big pitfall everyone needs to be aware of. But that said, there are ways around it. There is a solution. The solution is to be able to start with modules which doesn't really require those jobs to have those. Meaning jobs which require licenses, require IPs and PDKs or dependencies. Start with moving those jobs to the cloud and having as a function. That way you're not affected. Right. So once we build up that confidence and trust, and there's different programs, from the federal government, RAM, FedRAM, where you can get your CSP certified, your tool certified, so you exactly know how to transact with customers' data and then IPs and PDKs and dependencies, which will help you fasten this process of adoption. So again, at the end of the day, it boils down to trust. And if your customer is able to trust that you're able to handle their entire workload efficiently, in a smoother way and in a cost-effective way, adoption is going to be fairly quick.
Yeah. Any other comments on this one?
Yeah, I think so. I mean, we have clients that, there are more than a couple clouds that have a GovCloud version of them. So our platform kind of runs on top of the hyperscalers. And it does go down to trust, but it also, you can, all the clouds, you can encrypt your data. A lot of them, you can even own the key yourself. And, you take smaller workloads at a time, and you'll notice over time that a lot of the clouds have a lot of traceability. So if you can dictate, what region the data runs in, where it lives. Like I said, you can encrypt it and keep the keys yourself. So I think it's just an adoption problem. And then once you get if you have an IT office or a security office, once they get used to how these different providers run and what type of they're very transparent generally. So any certification you need can be done in the cloud as well. It just takes time and agreement with everybody involved.
Yeah. So it seems like we're heading in the right direction there, at least. And just seeing on some of the slides Rajath had put together, and it's not a typical talk. It is a panel discussion. But for those in the audience who may not be familiar, give us a quick rundown on what we're seeing here, and why we need different cloud solutions as the platform to make all this work.
Yeah, so just to summarize things, if people are not aware of the architectures. So the Amazon EC2 instance is elastic compute instance, which is still fairly monolithic. Of course, you can move to this, which still has the same problem, but eliminates a lot of the issues from an on-prem deployment. From an AWS Lambda function is what we have talked about. Functions as a service, or AWS Lambda, which is much more granular, which has less rigidity. It's faster for you to debug. And the downside again is it does cost more, because the total cost it's a paper use and compute model, where that function gets triggered by an event which was previous to it, and it only turns on because the previous event asks it to turn on, which is not on all the time. That means you only pay for the number of times you access it and the number of minutes you used, versus an EC2 instance, which is on all the time, and you pay for all the services even though you're not using it. I'm going to move this slightly here. And then the other downside for functions as a service, of course, there's a lot of great talking points to it, but because of its latency, because of its cost, there is a maximum runtime about 15 minutes. So your function which you define can be called, and like you return a function after 3 hours. All of the function call needs to get returned within 15 minutes. So that's what you get, and you pay to only access it for that moments of time. But if you're able to split up a big function into smaller chunks which are non-dependable, you've got a great architecture for you to scale without. Yeah.
That's one thing, with the EDAs, their cooperation. If we can get an interface or a specification for these type of things, the different providers, we might not have that 15-minute limitation.
That's
so
right.
if you can package or containerize your workload or however you need to do it, but the big key here is the cooperation from the EDA vendors. So
That's right.
we need to know, what is the specification and what is the interface to hook up to.
Yeah.
And I think, you might see the overall theme kind of that we're talking about is you want everyone to get higher utilization. So when you're offloading your workload in the cloud and you're having these compute instances, you pay for when they're on. So you want to make sure they're utilized. So if you have a monolithic architecture, it has to be on the same machine no matter what, because that's what it's running. That's your VM, that's what it's running on. So if you're running at 10% utilization for part one, and then it goes to the floor planner, and you use 99% utilization, and then you go back and you do some other things, maybe you have a machine type that's 5 times more expensive than that you need, but you only need that expensive part for 30% of the runtime. So I hope I'm not putting words in your mouth, but I think utilization is a bigger theme here and what we're trying to enable in the cloud.
Yeah, as moderator, my job is to get this exact kind of discussion out of you guys. We only have a minute and a half left. Are there any questions, or is there anyone considering using HPC for simulation or other EDA functions and have questions for the experts while they're here? Really? Okay, well, here's one. Great.
So, hello guys. I want to ask, at some point in the early presentation, in the early part of the presentation, you mentioned about workload prediction, that you have no idea how to estimate the workload, and therefore you cannot give an estimate on the cost for the
Would you mind
client.
stepping just a little closer to the mic?
Okay. I wanted to ask you, so is there anything close to decent when it comes to workload estimation, and therefore help you give an estimation to the client? And if not, what do you see is the biggest problem to current workload estimators for your use cases?
I think there are solutions right now, but some of it does require manual work. Part of what I'm sure what Ken and I do as part of an onboarding process are to benchmark models to try and provide an estimation. And so if we know, from benchmarking efforts we've done in the past, even if they're micro benchmarks that we can extrapolate from, we can provide estimations from there. But it is a manual process that can be automated. I think what we can do from gathering metadata from different types of applications and hardwares and runtimes is build up a library of information that AI and ML are perfectly suited to try and help us make predictions, and then we refine from there. So I think the short answer is it can be a manual process now, but as we start to gather more information, we're building what we think are recommendation engines and prediction engines that not only should help you pick the best performant hardware for your application, but also give you a good idea on how long we're going to think it's going to run based on some of the characteristics of the model. But there's still definitely work there to do.
Yeah.
Good answer.
Rajath, any comments on that question?
No, I think he answered most of it.
Yeah.
Yeah.
You? Yep.
Yeah. I think that's good answer. I think I think from user more transparent upfront kind of monitoring really give us the kind of confidence and really can really adopt this more quickly. Yeah, as a new technology. Yeah.
It's also, I guess, quickly. So if we all embrace the FaaS type model, these are simpler operations, and it's actually easier to estimate that. So right now, when you're bursting out, the whole application in the cloud, we don't we only know what license it checks out. We don't really know what it does underneath. So it's, but yeah, if we get enough adoption, certainly there can be models to better, pick your pricing. And then maybe the EDA application itself will know, okay, this isn't beneficial to go to the cloud, let's just compute it locally.
Yeah, it comes back to what you said earlier too, Ken. If we could come up with a standard library of functions that are needed, then even down to one individual function, each can have a price.
Exactly.
And so many sesame seeds, and then we know what needs to run to complete the job. We can actually accurately price that. One last question.
So with the 15-minute limit, what happens when you get to 15 minutes? Is your job killed? Or is
great
it
question.
like checkpointed and restored later?
Go for it. I think you are the next person to answer.
So it depends on your on the platform, but generally you don't have enough time to checkpoint it. So it's generally that job will fail. That's not always the case, but generally you receive the signal and you maybe 15 seconds to do something. So you're not checkpointing anything at that point. I don't know if Ryan has.
I'd say there are tools we build on top of it. Certainly the cloud providers aren't going to do a lot there. I think the Lambda functions operate similarly to spot instances for EC2, where you're launching on hardware that they have off to the side that they can requisition at any time. So if you're not prepared for it and it's requisitioned or a Lambda function is stopped, you may be in trouble. But part of what orchestration engines like Rescale and others can provide are to build tools on top of that, so we can implement auto checkpointing that may checkpoint at certain increments, and it's taking backups to ensure that if an instance is spot killed on EC2 or a Lambda function is terminated, that we're automatically restarting, maybe on another spot instance, maybe on just a dedicated on-demand instance, and then we can restart from that checkpoint. So the cloud providers do at least provide us with the flexibility to build that level of orchestration on top of their tools, and that's something that I think we need to build out more tools from that. It seems that from their stance, you kind of know what you're getting into with Spot or Lambda functions as far as those kind of immediate stops.
Excellent. Well, thank you. We're over time now, so we will finish. If any of you did have any other questions in your mind, I'm sure we'll all be happy to stand up the back there and talk to you in person to person for a few minutes if you would like. So thank you all for attending.
Thank you very much.